All right, so here is homework. Not homework, I keep saying that. Here is practice lesson 4.2. So the first question is telling us to reflect triangle PLX across line y equals x, and then label it P prime L prime X prime. Well, first you have to realize what uh, line y equals x is, and if you can recall, line y equals x is the one with the positive slope of 1 for 1. So every time y goes up 1, x will go up 1. So it's that one that I highlighted just there. So I'll just go ahead and keep that highlighted like that'll call the turn red. Okay. So now the best way to do this, in my opinion, is to keep exercising the table method. In order to exercise the table method, you need to kind of know what the equation or the um, algebraic description is for a reflection across the xy axis. So in this case, it's x comma y, like every other one does. And then the arrow, and then for a reflection across the xy, it's going to be y comma x. That's as simple. That is what x turns into y and y turns into x. Okay, so we set up our let's call PLX a blue triangle just for PLX blue triangle, and then we'll turn since we're going across be blue. So since we're going across the y equals x and it's red, we'll make it red. All right. So let's go ahead and start our points. So we have P, it's supposed to be blue. Let's make it better here. So we have P, L, and X. And let's make sure we get our points right. All right, so P is -2 and -2. -2, -2. This is X and Y. Okay, L is -2 and -4. -2 and negative, well, big negative sign, slip on me. -4, -4. Okay, and then X is -4 and -5. -4 and -5. Okay, and then our X, our YX. So our change, our X's are going to be Y's, the blue Y, and our Y's are going to be the X down here. Okay, so our reds are X or Y's. Y is going to be -2, -2. Right there on the line, so that makes sense. Okay, and then it's going to be -4, -2. Then it's going to be -5, -4. Right, so I grab a little these things to fill solid red, and let's go ahead and that's one of ours. -2, -2, -4, -2 is our next one. Right there. I don't know why that's not supposed to be red, whatever. Okay, and then our next one is -5, -4, -5, -4 is our next one. Okay, and then we'll connect the dots with the line. Okay, so this here oh, I made a mistake. This should be -4, -1. This should be 1 here. Again, being careless, this should be 1. That should be 1, making this 1. See, because that's 1. So that should be -4, -1. So it should be -4. And that should be -1. So this should be up here. We'll go ahead and this and just that real quick. Okay, this happens if you're not careful. Make one of those mistakes almost every time. Okay, so that looks better. Okay, so that's our reflection across the XY. Okay, key to this is knowing this algebraic description, and then knowing how to write the table, and then of course pulling your numbers off correctly, your points off. If you're careless like I was, you will make the mistake that I did. Okay. Then draw the reflection of FWD across let x equals -y. We'll make x equals -y green. That's this line right here. See if I can be a little less careless this time. Okay, we'll make x equals -y. We'll make this purple 1. This purple 1 here. Okay. And I guess I can make it like this. That's the way I did the other one, I guess. Consistent. Okay, and it's going to reflect it across this. We're gonna label it. Oh, I didn't label the last one. Finish the directions. All right, so this will be P prime. This will be L prime. This will be X prime. There, now the last one's finished. Okay, so now we need to reflect it PFWD across the green one. I'll make it green. But I'm gonna go ahead and get the points for FWD. We'll go FWD. All right, so I'm gonna be a little more careful. F is -5, 4. -5 and 4. W is -2 and 2. -2 and I almost did it. -2, -2 and 2. Okay, and then D is -4 and 1. -4 and 1. Okay, so what is my reflection across the x minus y? What is that algebraic description? Well, if I go back in my notes where I memorized it, it's xy yields -y, -x. Okay, it's kind of like the other one, except everything is negative. That's how I remember it. All right, so it's going to be -y is my x values, and -x is my y values for my prime. So this will be f prime, this will be w prime, this will be d prime. Okay, so let me go ahead and fill this out. All right, so my x's these are going to become my y values, but they're going to be negative. All right, so this is going to become 5, 2, and 4, and these will be my y values. So the x, my y values of the new one. So, all right, so these are my negative x values, or it can become my y's. So I'm going to fill out my y's. All right, so this is going to become 5. -2 becomes 2. And -4 becomes 4. All right, and then I'm gonna do My y values, they become negative, -4, -2, and -1. Let me go ahead and plot these. All right, my x is -4, and my x value is 5. So let's put it right here. This is f prime. F prime. My b value, my w value is 2, -2. It's the same thing. This is w and w prime. Same value. And -1, -1, and 4. That's my d prime. D prime. Grab my straight line drawer. Here to here. From here to here. And I go from here to here. And that is my reflection across x, y equals -x. That low one looks correct. Okay. So let's move it on to negative number 3. Select all the triangles that are a reflection of CHY. So CHY, let's see what are a reflection of CHY. Well, let's go down the line here. Is FWD a reflection of CHY? Well, yes, let me go ahead and clear all the, I don't have to clear it. All right, so let's say is C, I'll clear it. Why not? Let's, it's the easiest way. I'll just copy and paste over it. Yeah, that's the best way to do it. Okay. All right, so what is a, let's see, what's the best way I could show this? I think I'll just do this. All right, so is C, so what is FDW a reflection of CHY? Well, instead of just going like doing the values every time for this and like plotting things in, let's just look at it intuitively here. Let me copy this. I'm just gonna paste it. Okay, well, let me see if this thing will reflect. I'm gonna copy this. I'm going to rotate it. I'm gonna rotate it 180 degrees. Well, that's not what I'm gonna do. Let me go ahead and not do that. Control Z. Control Z. Control V. All right, so let me see if it happens if I invert the selection. No, that's not well, Control Z. I'm just messing around here. Okay. Well, let's see what would happen if I would to go across flip across the y-axis here. Well, is W and Y the same value up from my y-axis? Well, it looks like it is. Is C and F the same value from my y-axis? It looks like it is. Is D and H the same value from my y-axis? It looks like it is. So I would say that, yeah, I think that FDW is the same, is one of my reflections. Okay, what about XLP? Is XLP a reflection across something? Right, well, I don't know for sure. Is it a reflection across this? Well, let's take a look. Is it 1, 2? Okay. Well, that looks like it's 2 from the origin. How about this? It's about 1, 2, 3. It's about 1, 2.5. And this is about 1, 2.5. Okay, that's about 2.5 from there. This is about 1, 2, 3, 4.5. And this is about 1, 2, 3, 4.5. Yeah, so this looks like it is indeed a reflection across x negative y. If I wanted to really verify this, I could plug in the numbers and now would see that this relationship would exist. And I could actually just spot check it. right? I got -4, -5, and look at this, I have 4, 5. So that relationship does indeed exist, right? I have 4, I have -5, 4, and I have 5, 4. This relationship, when I have a relationship across the x-axis, remember for a reflection across the y-axis, the y values stay the same, but the x-axis value becomes negative and positive. So that's reflection across the x-axis. So let's see what else. What about RVN? Is RVN one? No, that's way off. Doesn't even look close. It looks like it could be a rotation though. Yeah, probably most likely a rotation, but not a reflection. Okay, what about ZXB? Oh, sorry, ZKB. ZKB. Well, let's see. Let's look. Well, that's 1. That's 4 and 1. And this is 4 and -1. Well, that looks like it's at the x-axis, the x values, or the x values stay the same, but the y values flop in sign. So that's most definitely a reflection across the y-axis. Sorry, the x-axis. So most definitely that. Okay, and then we have PLX prime, which we had over here. But no, that looks like probably it would be a 180-degree rotation, if you can remember what that looked like. And then FWB or FWD, that was over here, and that looks like it probably might have been a 90-degree rotation if we had it available. So that's not one either. Okay, all right. So it's just these 3 right here. Okay, moving on. The algebraic description of the reflection BX Z was a pre-image onto NVR, and it was this value, -y, -x. Describe how the coordinates of BXZ in the pre-image coordinates NVR, the image can be used to describe the reflection. All right, so they're talking about BXZ and NVR, these 2 right here. And it's saying, hey, this thing here, the original was this was the pre-image, this was the pre-image, and this was the image, and this was the algebraic description. Well, this is pretty much what we've been doing before. If you just pick a point, any one of these points I picked, which one did I pick? I picked K and V, your corresponding points. K was 4, -1. K was 4, -1. Was 4, -1, and V was 1, -4. And then all you got to say here is that the coordinates switch places, the coordinate values switched places. Maybe it's bigger a little. While the a figure reflected across line x equals -y. The signs shifted as well. So that's what I put in there. I think that's satisfactory. Okay, so the next one is which triangle is the image of FWD across the x-axis? All right, so FWD across the x-axis. Well, that was the original, the PLX, um, the the post image of PLX that we drew before. That was the triangle. Should let that up. This I was triangle. Was it X prime, L prime, P prime? That was the one that we drew up right here. It was like this. Yeah, it was like that one, something like that. That one there. Okay, the next one we have is what was the which triangle is the reflecting image of CH, triangle C, YH, CHY across the y-axis. So across the y-axis, well, that kind of narrows it down. There was one over here too, but you can see that you have 2 and 2, and then 2 and -2. Right, so when you flop something across the y-axis, the x-axis changes in value, whereas the y-axis stays the same. So our FDW here is reflecting CHY. So the answer is triangle FDW, FDW. All right, so the next thing here is describe how the coordinates of FDW, which we don't have anymore anyway. This one was, let's see. I can delete some stuff here. Oh man. I'll just go ahead and copy this thing again. Down there again. And describe how the coordinates, go ahead and draw these things again. We had this here. There. And we had it. This was 2, 2. It flopped 2 negative. Oh, this is right here on the thing. Yeah. And then this was 4, 2. So we'd make 2, 4. That was too skinny. This had to be 4. Yeah, over here. Yeah, that's right. Okay. It feels like that. Okay. Try by the coordinates, vertices, F prime, W prime, and XPXL, XPL can be used to determine the algebraic reflection. All right, well, we had, this was F prime, and we had an F. So we had F prime and F. So I just did, F was -4, 5, and F prime was -5, 4. Right, so that relationship was y, x. So the algebraic description would have been x, y yields y, x. Y, x. And that's a satisfactory answer for that. It's just describing how the coordinates of the pre-image can be used to determine the algebraic reflection. Right, these are the coordinates, right? And once you know these coordinates, you can relate how those coordinates change, and when you figure out how those coordinates reflect upon each other, then you can figure out what the algebraic description is. And that's all that what it is. And this is the same thing for this one too, right? The same thing for this one here. We had K, ZX, ZKB. We had ZKB, as compared to CHW, and I'm going to compare K to H, K to H. So K is 4 comma -1, 4 comma -1, and H is 4 comma 1. So the relationship, so the x's stay the same, and the y's flop by -1. Right, and they don't, and the x's and the y's don't change position. Right, so the algebraic description would be x comma y yields x comma -y. Why did I put -1 there? It should be -y. Okay. All right. Then next is write the algebraic description for NVR, the preimage into PLX, right? The preimage. So this is pretty much doing the same thing. So NVR onto PLX. We have NVR onto PLX, and we're going across the y-axis. So this should be just something that you already know. You're going across the y-axis, so it's x comma y, and you know you're going across the y-axis. So the y stays the same, the x changes, and it's that one. Okay. And then the next one is P prime L prime X prime onto BKZ. Okay, so the prime was up here onto BKZ. So it looked like this. And then it was like 4, 1, -1. So it would have been like 4, -1. It would have been that one. And that would have been like 5, 4, so it would have been like 4, 5. So it would look like this, except not like a little notch do. Right, so let's do that. Yeah, there you go. Better. Okay, so it'll been like that. Right, so it's talking about this one going to that one. Okay, so but since we're going over the y-axis, it's again the same thing. You're flipping over the y-axis, right? So the x comma y, like every algebraic descriptor starts, and if you're flipping over the x-axis, over the y-axis, the x changes, and the y stays the same, and the x and the y stay in the same spot. All right, so that is how you do homework 4.2. I hope that helps out.